The talk is, I guess the title is, Can Adversaries Play a Positive Role in Ethical AI? And to tell you the truth, I really don't do too much work in privacy and security, so I figured I would just give a bit of an outside perspective. We've had a lot of like really amazing kind of high protein talks today with nice theorems and really compelling experimental results and some very nice epsilons that I saw. And this, I'll talk about a little bit about some technical contributions, but it's mostly, think of it more as like a little celery and watercress salad to kind of refresh us and get us ready for the discussion. Not everybody likes celery, but okay, so good. So I guess I'll just start off with what I think is a very uncontroversial claim, which is that data-driven prediction technologies are really having a huge influence on our contemporary lives, and for the foreseeable future, as far as I can imagine into the future, I think that's going to continue to be true. So in terms of trying to think through that influence, it can be helpful to take a very, very coarse-grained macro perspective on this. This is a diagram that I've adapted here from Mannheim and Kaplan, evoking the idea that in terms of how data and society interact, we can think of a kind of an interplay between business, government, and civil society. So you can imagine that sort of business is doing some activity, maybe making some models that have some sort of privacy or security properties, and that might induce some sort of government regulation up to sort of legal standards. And that can have also some like knock-on effects for normal citizens. We're kind of sitting here perhaps, which could, for example, mean that we have to like click and accept cookies like every website we go to. That's like an effect of regulation. So I guess like one of the hot takes or one of the things I'll offer today is just in terms of problem scoping. When you want to make a technical contribution, it's very important as one of the first steps to establish what is going to be the scope of your contribution. And at least from my outsider perspective, looking in on privacy and security research, I tend to see the scoping happening mostly from the perspective of the kind of corporate firms. So for example, developing algorithms with a certain privacy properties in the idea that they're going to go to market and be suitable for, sell to a business or to consumers. And also I see plenty of papers that are taking the perspective of, can we come up with some sort of auditing procedures to guarantee a degree of compliance or, kind of establish that these businesses are doing what they claim. But I see a lot less that focuses on what kind of technical contributions could we make within civil society. And I would tend to agree with this quote that I have on the slide, that civil society has a very important role to play as we think about how data-driven technologies affect our lives. So another way to motivate this talk is just when I said we want to make a technical contribution, it involves some sort of scoping. Another important step is to establish what are your technical assumptions, right? And right now with machine learning and AI, we're in a moment where the rubber is really hitting the road, and we're testing some of those classical assumptions from statistical learning theory and the sort of academic work. So one example would be the IID assumption, this assumption that says that we think our data are independent and also identically distributed. And this is a very convenient assumption for us. It's going to sort of authorize standard ways of splitting our data set into training and validation. It justifies maximum likelihood learning and so on and so forth. So this is like kind of bread and butter of machine learning, but somehow in the real world, we should be wary. We shouldn't trust this assumption too much. Like we know that our data distribution could shift over space or time. And so building real world machine learning systems somehow is about relaxing these, in reasonable ways, relaxing these assumptions that are convenient but somehow unrealistic, right? The distribution shift is one example. There's many people machine learning community working on out-of-distribution generalization, which
what we call domain adaptation.
sure. No, it's definitely not something new. So I guess on the previous slide, I was arguing that, and I think you would agree with this, is that people are starting to realize, oh, we really need to care about this problem. Practitioners especially, yeah. But that's a great point. This has been an active area. Of course, yes, of course. Anyways, so Shai makes a good point. Like, these assumptions have been challenged from the academic community for many, many years. And so I'm not trying to undermine that claim. One kind of way that I think about the IIC assumption here, and we could call this, let's just call this domain adaptation instead of out-of-distribution generalization. But really this is focused on the second half of this assumption, identically distributed. But this assumption has two parts to it. And the first part, I would argue, is just as unrealistic, right? So data are collected from society. People have relationships with one another. They don't act in isolation. They could be working towards the same goals. They could be competing against each other. We don't tend to look at like non-independent statistics because that's technically very hard. I mean, if you go into like the Gaussian processes literature, you'll get sort of, if you're familiar with GPs, you do see non-independent statistics, but it's not very mainstream in terms of machine learning. So I'm very interested in thinking about civil society as composed of people who are acting non-independently. And so far I've just basically been using the time allotted here to try to motivate what I see as a little bit of a gap in the literature. And there are some interesting works I've seen that suggest that populations could coordinate amongst each other to exert some sort of data leverage on the other nodes in this kind of triangle here. And so this also like calls into question some of our very most primitive concepts in privacy and security, such as the adversary, right? We're thinking oftentimes in terms of red teams and blue teams. But of course, whether actions are adversarial or not is really a matter of perspective. Okay, so there's some very interesting survey paper on the politics of adversarial machine learning that I think many of you might be interested in. So that sets the stage for me to talk about what I think is a very contribution in this space, which I'll talk about next, which is about algorithmic recourse. So our algorithm we called online algorithmic recourse by collective action, or ORCA for short. I'll need to explain the setup here. First, algorithmic recourse is a problem very closely related to explainability in machine learning. So the main distinction here is that we need our explanations to be actionable in the real world. So think about, for example, some sort of lending setting where an applicant is filling out a loan. Those loans are going to be, the application here is going to be rendered into some feature space X. So think of just like, taking all the text and putting it into a BERT model, or maybe it's like a form, you have some sort of categorical features. This is where the machine learning happens, right? There's a bank or some other sort of financial institution that is learning a model based on labeled loan applications. And what they're really trying to do is make a prediction, f of X, which gives a sense of the loan, the credit worthiness of the applicant, and they're going to use that to either approve or deny this loan. So we can say that the model F has some recourse property to it if it's the case that it returns not only a classification or a prediction, but also some reasonable, actionable perturbation to the features delta, such that if you apply that perturbation, so think of this as going and getting a guarantor for your loan perhaps, or paying down some of your credit card, it needs to be something actionable. But if you apply that perturbation onto your features, you're going to arrive at a more favorable prediction in the future. And I want you to notice here that this is like an inherently individualized problem setup. All of the recourse is done on an individual basis, and it's assumed that each of the individuals is kind of acting independently on their own recourse suggestion. So this is a very kind of generalized full model where I've got a simple classifier with 3 different categories here. Star represents the one individual who's seeking some recourse. I colored the star orange because that's really the class that they want to be. They want to get over this orange region, the decision boundary here. This delta perturbation is kind of saying, well, you know, if you travel in this direction, you might get there eventually. But of course, it seems like for small perturbations, this individual is not going to be able to get to their desired part of the feature space there. So what we did in this paper is really, you know, it's mainly just a conceptual contribution. It's quite simple, but we're just trying to pose the problem a different way. We're imagining that there's a notion of collective recourse where these data subjects are actually coordinating together on somebody else's behalf. So imagine now that this orange star is affected but disadvantaged community member or someone who either is directly somehow indirectly needs additional resources in order to achieve what their goals are. So we have this idea that data subjects can act collectively to achieve recourse, but you should know that this only really makes sense if the model is adapting or learning online in response to these perturbations. Otherwise, if you're just interacting with an API, this type of recourse really isn't possible. So formally, this is really very simple. All we're imagining is that you're kind of searching for a collective perturbation such that our data target is getting their recourse, but this is also going to be a reasonably small perturbation vector. And like visually speaking, what this means is that to make a very small perturbation in this feature space, the model itself updates. Star points hasn't actually moved in the decision boundary has moved. Any questions on this? Yeah.
Why is the model that? I want to know who can belong to it or not. That is a group of people. Doesn't mean that how they can belong to it.
Yeah. So
I have some boundaries.
Sure.
Boundaries will change actually.
Yeah, so I guess there's different ways to answer that question. Model retraining happens all the time in practical settings. And you could imagine that the lending firm, their own kind of financial situation and incentives might change year over year. They're also engaging in a market that's changing dynamically. That's the thing I can't fully answer is that, you know, they're making predictions about data, what I'm calling data subjects here. I think it's reasonable to assume they're going to change their model over time, but they might not change their model over time in response to predictions they made for their consumers. Yeah. It could be, yeah. So there's lots of open questions here. And like I say, this is mostly just like a provocative kind of conceptual contribution. I mean, to understand it in a different context, not in the context of algorithmic recourse, but people have talked about the sensitivity of large language models and other sort of like very large generative models, the sensitivity to small changes on like the internet, which composes their training data. So you could imagine the case that loan applicants are changing the bank's model. Maybe it's the case that there's a community of internet users who are updating their, updating their academic websites. And we've actually seen instances of this where you can like inject a prompt simply by editing the HTML of your website, and that can affect, you know, Bing or some other large language model based kind of chatbot or search engine. It can affect its response. Hopefully that answered your question.
The setting similar to poisoning, so it's a positive poisoning.
Very similar. Yeah.
But it's not adversarial. I mean, the way that we are using
I like the way you asked that question because
because you are changing.
The methods are almost identical.
Yeah.
But one difference here in the collective recourse setting is that the collective doesn't necessarily need or want to sabotage the model. They're just trying to, and so I'm interested in what would it look like for a community to guide a model that they don't control towards a more fair solution. Maybe that there's some firms acting in the market that don't have the incentives or even resources to make the model fair or perhaps even private. I haven't really thought that through.
Healthy poisoning.
It's like healthy poisoning, yeah.
So when I'm seeing these, when I'm seeing them sort of reorient themselves, it's really reminding me of how models adapt a domain shift. Like when COVID happened.
Yeah.
So what's the logic you use to kind of determine where they would recourse? Is it based on how we adapt models to a covariate shift or a domain
change?
It
definitely could be. So I think actually, hold that question for a moment. I think what I want to do just in the interest of time and also because I want to, the last two questions basically the next two slides, so I want to progress a little bit. I can definitely do that. Great. Okay, so it's related to data poisoning, super related, and it was really interesting for me to hear experts on data poisoning give talks and posters today. And let's talk more because I'm very interested in those connections. But as you pointed out, it doesn't necessarily have to be a sort of a sabotage of the system. It could be sort of a more targeted guiding of the system. And I also want to point out this really nice paper by Moritz and his group because it relates to the distribution shift question. So I tried to motivate this by saying, okay, IID assumption. There's the distribution shift portion and there's the independence portion. And in my research, I was really thinking that independence would be the key aspect, but they're not easy to disentangle. So this is Moritz's paper. He's thinking along similar lines. He has a very nice theoretical framework to try to get some intuitions as to what's going on here. And he takes more of a distribution shift angle. So says that if you know data poisoning, this is going to look familiar, right? So you have a training data, and there's going to be some small alpha percentage where the collective can control that distribution, but mostly it's some base distribution. And he has some nice theory. In less than 1 minute, I can't really describe it, but analyzing the success of not the attack, but the collective success as a function of the size of the collective alpha. So you could also reasonably approach this from a distribution shift perspective. Yeah, so lots more to be done, and I'm happy to I think, I'm happy to hear that there's lots of connections. I see those connections as well, and also happy to chat with people if they want to work on this kind of topic with me, or just exchange some ideas. So thanks for your time, and appreciate any of the questions that we've had so far.
Cool. Yeah, maybe we can take another question or two. Can I change in the picture you showed? Can I change the star itself rather than asking everybody else to change?
So you would like for the collective to make a perturbation that changes where in the feature space this is?
Yeah. What I mean is I want to change the minorities here. Okay. Let me give you the context why I'm asking.
Well, I mean,
yeah.
This is a very simple stylized example. I don't think it's especially practical. And in fact, it's a non-parametric classifier. So the classifier itself is just a nearest entropy type thing. So it's not really a notion of learning happening. It's you have the data and you just have your classification on the data. When I hear your question, I think what interests me in that question is, what if there's a learning process? What if the firm is learning an internal representation in some model? Could the collective act so that the star arrives at a different place in that representation space? I definitely think that is possible, but I haven't thought too deeply about it yet.
Just to that point, if the star just to that point about the star moving without the entire kind of paradigm shift, wouldn't that just be a next best action kind of generation where you're saying, you can get here.
Are you talking about like best response function?
Yeah, kind of. I mean, like you're just saying, okay, this is where you're positioned, you're the star. But if you want to actually go and fall into the orange category, you do X, Y, Z, you improve your credit score, you follow like the 3 steps, and then you can reposition yourself.
You could think of it as kind of a collective best response strategy, and there's definitely strong collections with strategic classification, if you're familiar with that. So I'll just leave it there. I think I'm out of time, but happy to talk with you afterwards.